Hello and welcome to another Orange Coast College mathematics video. In this video, we're going to learn to rationalize the denominator. I'm going to assume that you're familiar with simplifying radical expressions. Now, what is rationalizing the denominator? What does that mean? So when we have a fraction or rational expression, it's not considered simplified when we have radical expressions in the denominator. So this is a technique for removing radical expressions from the denominator. Now there's one useful formula that you might want to keep in mind, which is if I have a two-term expression like this, where I have a, and then I have, say, plus a radical expression or minus a radical expression. If I multiply together this expression by its conjugate, which means we have the same two numbers here, but we have the opposite sign in between them, this will actually remove the radical expression. We have these square roots, right? We have a minus the square root of b times a plus the square root of b. This will give us a squared minus, this is b, which is the square of the square root of b. You don't have to memorize this, but it might be helpful for later examples. Our first example is a relatively simple example. You might end up with something like this as the answer to a problem when you're solving an equation of some kind. So how do we rationalize the denominator? We're going to multiply this fraction by 1. But what we'll do is we'll write the number 1 as the square root of 3 over the square root of 3. So multiply this by the square root of 3 over the square root of 3. All we've done here is multiply the number 5 over 2 root 3 by 1. And now we do this. So we get, on the numerator, we get 5 times the square root of 3. In the denominator, we get 2 times the square root of 3 squared. And of course, that will simplify into just 3. So we get 5 root 3 over 2 times 3, which is 6. And we want to make sure we cannot simplify any of these factors here. 5 and 6 have no common factors, so we're done. And now, instead of having the radical in the denominator, we have a radical in the numerator, which is preferred. Example 2. Now again, when I have a radical expression, and only a radical expression, in the denominator, I'm going to multiply this whole thing by 1, but in the form of the square root of 5a cubed over the square root of 5a cubed. So we write this, multiply this by the square root of 5a cubed over the square root of 5a cubed. And so what we get is, in the numerator, we get 1 times root 5a cubed, which becomes this. And in the denominator, we simply get 5a cubed. And now we no longer have a radical in the denominator. Example 3. Our technique from the previous two problems won't work. If I multiplied the numerator and denominator by root 7, I would still have a radical when I was done after I distribute it. So what we're going to do, though, is we can use that formula we had at the beginning of the video. That is 4 minus root 7. If I multiply the numerator and denominator by the conjugate of this, then I will no longer have a radical expression in the denominator. So the conjugate of 4 minus root 7 is 4 plus root 7. So I will multiply the numerator and the denominator by that, so that I'm only multiplying by 1. Okay. And now, so in the numerator, we distribute. So we have 3 times 4 is 12. And then we distribute the 3 to the second term to get 3 root 7. Now, once we multiply 4 minus root 7 times 4 plus root 7, we use the formula in the beginning, we'll get the first term squared, 16, minus the second term squared, which is just 7, right? The square root of 7 squared is 7. And so what we end up with here is we end up with 12 plus 3 root 7 over 9. Now, the last thing we can do is we can just take each term and divide it by 9. So we get 12 over 9 plus 3 over 9 times root 7. And then each of those terms can be simplified. So we have a common factor of 3 from the first one. So we cancel out the 3, we'll have 4 over 3. And from the second one, again, there's a common factor of 3. We cancel that, we'll have 1 over 3. So this leaves us with 4/3 plus 1/3 root 7, or you could write it as root 7 over 3. And that's it. For our final example, we use a similar technique to the last problem. It ends up being a little bit more complicated, but it's the same idea. So again, to rationalize the denominator, we want to multiply the numerator. Sorry, we want to multiply this whole fraction by the conjugate of the denominator, but we want to do it to both the numerator and the denominator. So in this case, since the denominator is 3 minus root x, the conjugate is 3 plus root x. And if I multiply by 3 plus root x over 3 plus root x, all I've done here is multiplied by 1. So we have to distribute the top. So for the numerator, we first have 1 times 3, and then plus 1 times root x. So that will give us 3 plus root x. And then we multiply the second term by both of these. So we'll have root x times 3. And then finally, we'll have root x times root x. That will give us x. In the denominator, since we have this 3 minus root x times its conjugate, we'll just get the first term squared, 9, minus the second term squared. And now we simplify. So in the numerator, we'll have 3 plus x plus 4 root x. And in the denominator, we have 9 minus x. Now, if you could factor any of this and simplify, you should do that. But in this case, we cannot, so we're done. And that's rationalizing the denominator. So if you want to be able to simplify your rational expressions, you need to be able to master this skill. So practice it a lot. And until next time, have fun.